different loads all the way through the cycle, but it's just doing that little pump that's barely anything. When the dryer part comes on, it really kicks up the load. So, and there, once you put the thing on, that will cycle, so you have no control over it. So that's a fixed use. A dishwasher is. The water heater is. Sump pump, again, whenever the water comes up, it comes on. So you're not in control of that. And your water pump. You have the bladder tank in there that uses as a pressure facility for your house. And so the pump comes on whenever that pressure goes down enough. So again, you're not in control of that. And non-fixed, in other words, you're in control of when it comes on or off, is your clothes dryer. I can spell. There we go. And like Dr. Schultz's idea of spelling for engineers, you round up to the nearest letter. Okay, so.
Could oven be put there too?
The oven. Range was a different one. We already did that one. Had that other.
Why is your dishwasher fixed? How is it running if it's on?
Fixed in the sense that once you turn it on, its electrical demands are under control itself. So it's, again, it's different all the way through the cycle. So if you're trying to limit how much it draws and you turn it on, the dryer part, which is nothing but electric heat, will come on during that cycle and you're not in control of that. So you can't control the load profile of your house on these things, and you do with this one. That's really all they're separating at. So they count 75% of these and 100% of these. And so you can add all these, and there's a list in that example where you add that up and you can get that. And so then you just go through everything we've done and add up all the categories. And in this example, you ended up with the total was equal to 27,574 volt amps. And that's why you keep it all the way through in volt amps and don't convert it till the very end, because then you come in with the service. What is my service into this building? Well, if the service is 240 volts, I divide into that, and I end up with 115 amps. And that's what I was getting for the whole time. How big is my circuit breaker panel for this house?
That total was given?
Yeah, that total was everything we did over here, all these circuits and all these different appliances. There was numbers to all these and examples. And so you work through the examples, you end up with this total number, divide through by your service, which could be, typically, in our residences and our rural environments, it could be 240, it could be 220, it could be 208. One of those three numbers. So you have to know what's coming into your building. If it's 240, you get 115 amps. So if you have 115 amps, what kind of box do you buy? Next size above that, which is 150. You don't know that, but get a little experience and you would. And the little experience would be walk down the aisles at Home Depot or Lowe's and say, well, what kind of panel boxes do you have? Well, we got 100 amp, we got 150. We got 200, we got 250, we got 300. What do you want? Well, let's see. 100's too small, 150 it is. Next bigger size. And that's the thing where you have that continual argument with first cost versus long-term planning. I can save 50 bucks if I go with the smaller size, but I will have no option. I can't add anything. So think about it. If I know I'm going to have a 30 amp welder put in my garage, and I want a special circuit for that, that brings me up to 145 with nothing to spare. Nothing to spare. No addition. I'm a young family. I might have kids. It's a three-bedroom house. I might have 3 bedrooms and an office. I need 4. That'll be expansion. So, geez, long-term planning. I'll put a 200 amp box in here.
Is that the size of the box? What does that mean?
It is related physically, absolutely, the physical size, because, and why would that be?
To put more things in there?
Physically, to put more things in, absolutely, but as you have the bigger amount of power going through there, The spacing has to grow because you want a distance so arcing doesn't happen. You know, you get higher voltages, it wants to leap and arc. And so that's why spacing is critical. So the inside of that box is designed to make sure it doesn't, you know, arc inside there. And so, and that's why when you come into an electric, you know, let's see, a 4 box that's got 2 plugs in each side. Why is this story pertinent? Well, you can buy small, thin boxes that don't take as much room up, or full boxes that take more room up. When I rewired my garage, I bought the thin box. And there's a big complicated, you know, I shouldn't be telling this story. There's a big complicated formula that says conductors of a certain size, if you have this many conductors coming in this box, and this many going out of a certain size, then that relates to the cubic inches of the box with this formula, and you have limits. When I said, well, I can cram that in, geez, I'm just be careful. And so you cram all the wires in a thin mount box because I didn't want the thicker box on my garage wall. And I didn't want to bang a hole in the concrete block and bury it in it. And of course it didn't work. You cram it all in, you push it all down, you get all the wiring done, and then you have it all done, and turn the breaker back on, you hear this little tick. What's that noise?
Breaker flipping.
Breaker flipping. So you take it all apart again and look, and sure enough, you can find the little part where it arced. Oh crap, that's a little too close. So you move everything around again, you turn the breaker on, tick, does it again. I'm like, so if you're really upset, you do it a 3rd time. And if you realize after long years of experience that, you know, it's life telling you to do something different, you go out and buy the bigger box, you pull the old one off the wall, you rewire the whole garage again, and do it twice.
Electric tape it or anything?
And the second time it did it in second place. It didn't arc in the same spot every time. Yeah, because you move something in to make that not arc and something else would arc.
I know,
Yeah.
you put like a piece of rubber in between or something.
You probably could have come up with an answer, but you know, it was life's way of just telling me I was being dumb, that I needed to do it right in the first place. And that's usually you're not so lucky. Usually you get something to barely work, and then it'll fail down the road somewhere where you don't need it to fail, and it was really even worse.
So, you mean like a factory's plug-in would be big boxes because they have so much amp?
It doesn't matter what you have. If you just did a single box with a single duplex plug in here, it's got a requirement for so much space if you want to have that. And what I actually had in one of them that gave me the fits was a double duplex plug on this side, and then a switch on this side. And I actually toggled the switch on a light. Had power come in, power for the desk to the bench top, and then a light switch above. So I had 3 things going on in one box. It just didn't work.
So a mansion would have a deeper box compared to a trailer?
Yeah, yes, right. Deeper box versus the trailer. Because the trailer, now think about that. What are they doing in a trailer? They're making 1,000 of them. So if they save $5 on boxes, they save $5,000. You save 4 2x4s on how you build the corners in a house, and you save, every time you have a joining wall, protection wall, or everything else, you might save 10 2x4s per house. But if you're building 100 houses, that's 2,000 2x4s. 2,000 times $2.38 is another $5,000. If you come up with, you know, 10 items like that, and you save the company $50,000. Or you've made things so cheap they fall apart. There's a fine line there. Yeah, fine line. You have to watch out for that. So the real goal for all that was to put all this together to come up with the size of the box. When you come up with that, put the box on the wall and you're good to go. The next thing you do is start thinking about, and I always go back to commercial construction. In commercial construction, how do we build a building? We typically make a utility core and build everything around it. So if I have a cross-sectional view of a building with a utility core and I have all these offices around it, then I